The goal of exercise 7 is to continue exploring the addition rule and the multiplication rule of the ranks of matrices. So the boundary for the ranks of summed matrices and the boundary for the ranks of multiplied matrices. I hope that this visualization in this exercise will help you internalize these rules, these relationships. Okay, so what you want to do is generate pairs of matrices. They have to be the same size because we are going to add them together. And then you want to compute or define these matrices to have a specified rank and then add them together. And these are all random matrices. So we will assume that the ranks of the resulting sum and product matrices will have their maximum possible rank. Okay, so here you see the rank of A and the rank of B. And then, for example, in this particular iteration, this was one matrix had a rank of 8 and the other matrix had a rank of 4. Now, obviously, they need to be the same size, but when we added them together, the maximum possible rank is whatever this color corresponds to, which not surprisingly is 12, assuming that the matrix is larger than 12 by 12. Okay, so it's really interesting to see that the relationship between the ranks of the summed versus the product matrix is really different. And that's what you see here. This follows a diagonal pattern like this, and this follows this kind of square-shaped pattern over here. Now, why do we see this difference? We see this difference because the rank of A plus B, or the maximum possible rank of A plus B, is related to the ranks of A plus the rank of B, whereas the rank of A times B is actually related to the minimum size of A and B. Okay, so now I'll switch to Python and show you how I implemented this code. Well, I start by creating a function that inputs two numbers, two integers, m and r, and it outputs an m by m matrix of rank r, following exactly the same formula that I showed you in the previous exercise. Okay, and well, of course, these need to be square matrices because we are going to add them together. So let's see here. I just create some variables. So these are all 20 by 20 matrices. The size of the matrix doesn't really matter so much, except that it needs to be equal to or larger than the maximum possible rank that we want to use in these simulations. Okay, so then I have a double for loop. We need two for loops here because we have the rank of A and the rank of B, and we want to independently manipulate those ranks or specify those ranks. Okay, so and then you see these two lines of code are nearly identical. So I'm creating a random matrix of size R and here of size a different R. Here I'm adding them and here I am multiplying the matrices. And then I compute their ranks and then I make the visualization using a heat map. Okay, so I already showed you the results. And so I'm just running it here again so you can see that in real time, we do get the same results that I showed in the figure in the book.